Hello everyone and welcome back. My name is Mr. Kovalt, and in this video I'm going to be going over the equilibrium constant in terms of pressure. So let's get into this. So in a previous video I talked about the equilibrium constant and how to write the equilibrium constant, but we've been doing that in terms of concentration. So to kind of go back to that, here's our generic equation for our reaction. And we were talking about last time that you can write the equilibrium constant expression in terms of the concentration. So here you have your products, and you have the concentration of the products on the top, and you have the concentration of the reactants on the bottom, and all of them are raised to the power of their coefficient. So the coefficient for this product is little d, so you'll see that that's raised to a power little d, and the same for the others. So this is the way we've been writing the equilibrium constant. But the one thing we need to keep in mind is that from our understanding of the ideal gas law, we know that PV, pressure times volume, is equal to the amount of gas in moles multiplied by the ideal gas law constant multiplied by temperature. And so if we rearrange this in terms of pressure, so we see that pressure is equal to the amount of the substance in moles multiplied by the ideal gas law constant multiplied by temperature divided by volume. We could see here that we have an amount of our substance in moles divided by volume, and that is concentration. So we can view moles over volume as our concentration. And this is constant. The ideal gas law constant is obviously constant. But remember that our equilibrium constant is constant only under certain temperatures, right? So change the temperature, you change the value of the constant. So in order for this constant to actually stay constant, you need to keep the temperature constant as well. So if we remove the constants, then we have a proportionality, and we can see that the pressure of your gas or whatever substance you're dealing with, if it's a gas, then the pressure of that gas is proportional to the concentration. So we can write our equilibrium constants in terms of pressures or partial pressures of the substances we're dealing with here. So here's an example of an equation, right? So we have two moles of our sulfur trioxide gas is going to break down into 2 moles of our sulfur dioxide gas and 1 mole of oxygen gas. So we can write this as concentration. So we're going to distinguish between our equilibrium constant in terms of concentration and that in terms of pressure by the little c and little p here. So when we write our equilibrium constant expression in terms of concentration, then we do the exact same thing we've been doing, right? So we have our two products on top, so the concentration of SO2 and the concentration of O2, and they're both raised to their coefficient. So here we have a 2, so we have a 2 exponent there. Here we have a 1, so we have a 1 exponent there. We don't write the 1s, but they're there. And then we have our reactant SO3, so we write that, the concentration of SO3 down here, and it has a 2 coefficient, and so we have a 2 exponent there. So this is the way we've been writing that. But we can write it the exact same way in terms of pressure. Since we have gases here, they're all gases, that means they are exerting pressures. So we can rewrite this in terms of pressures. And so it's exactly the same, except for instead of concentration symbols, instead of the brackets, we have a P for the pressure. So the pressure of SO2 squared, because there's a coefficient 2 there, multiplied by the pressure, the partial pressure of oxygen. So there's a 1 there for the exponent of this pressure. And so it's raised to the exponent of 1. And then we have our 2SO3 gas. So the pressure PSO3 subscript here is going to be squared because we have a 2 coefficient here, so that's 2. So basically this is the exact same equation, except for instead of concentration, we're using partial pressures of our substances. So I hope this was helpful. I hope you learned something from this. If you enjoyed my video, if you learned something from this video, please hit that like button. Also subscribe to my channel. Hit that notification bell so you can be notified by other videos I put out. Put a comment in the comment section. Let me know what you think. Let me know if you have any questions. Thanks for joining me, and have a great day.